The last topic of model 3 which I am going to start is integration. Already I have explained the trapezoidal rule of integration, where I said you that any function, it will approximate as a straight line between the adjacent points and it will perform the integration. Similarly, there are other two rules. That one which I am going to explain now is Simpson 1/3 rule. Maybe you have studied in mathematics and it is there in your syllabus. So there you have done the calculation mathematically and you have solved the steps and you have derived the answers and etc. But Python language will perform within again one line command. Now, first of all, what Simpson 1/3 rule do in the integration? How it will integrate? Then, similar to trapezoidal, Simpson 1/3 rule will approximate any given function as a parabola between the adjacent points. Now see, initially it was taking as a straight line in a trapezoidal rule, but in Simpson's 1/3 rule, what Python will do? He will do the integration between the adjacent points by assuming as a parabola. Now that means you can integrate any function, but in Simpson's 1/3 rule of integration between the adjacent points, he will assume the nature of the function as a parabola. But let us consider, I have considered again the same equation, fx is equals to x square. This function is seems to be parabola because it is a x square function, and everyone knows that y equals to x square, it is a parabola, right? But now Simpson's 1/3 rule will approximate between the adjacent points, like between the lower limit and upper limit. What it will approximate? It will approximate this function nature as a parabola. Here it is a parabola, so you will do it. But you can change the function. Let us consider, you can consider fx is equals to x. Now what is your equation? It is a straight line, right? Fx is equals to x. If y equals to x, it is a linear function. It is a straight line equation. But whenever you are going to solve this integration with the help of Simpson's 1/3 rule between the lower limit and upper limit, that means between the adjacent points, it will consider the nature of the function as a parabola, irrespective of the functions what you have considered. Similar to trapezoidal rule, there he was considering between the adjacent points, that means between the limits, as a straight line, whatever function you have considered. But here he will consider the function, whatever function you have considered, it will consider as a parabola. Now, say, because I wanted to explain you the concept here, so it is a very simple. Again, from the SciPy, import integrate, numpy defined as np, and then define the function. My function is again x square. Then again define the limits with the variation of x. Let us consider again get one-dimensional array. So np dot array 1, 3, 4, total limit 1, 2, 3, and then for the total number of points which we are going to consider it. Now integrate dot Simpsons. What we will write? Integrate dot Simpsons y1 comma x, and it will give you the integration value. So see here, we need not to worry about any mathematical calculation. Just we want one command, integrate dot Simpson and y1 comma x. You will get the integration. But how it will perform the integration, which already have explained you that it will perform with the help of assumptions that between the adjacent points, that is between the lower limit to upper limit, the nature of the function will be considered as a parabola. This one was the Simpson's 1/3 rule. Similarly, there is the Romberg integration. We call Romberg integration ROM, ROMB. But it is a very simple integration. It will just integrate over the interval a and b. It will not consider any assumptions. Like, see, what was the trapezoidal assumption? Trapezoidal assumption was that it will consider the function between the adjacent points like a straight line. What was the assumption of Simpson's 1/3 rule? It will integrate and it will consider the function as a parabola between the adjacent points or between the limit points. But what do Romberg will do? Romberg integration rule, it will not perform any assumptions. It will just integrate the function over the interval. So my dear friend, it is a straight line integration, definite integration. If you have defined any integration, you just integrate it, that function, and it will not perform any assumption. So it is just straight away the integration, and it will perform the integration over given interval. So it is very easy again. For video, let us consider I wanted to integrate the function of y. So I will do the integration, and I will write it down, integrate dot romb y, and give the intervals of x, whichever interval you want. You start lower limit, upper limit, and number of points, how many points you perform, and it will not perform any assumption. So it is a straight away integration over the interval a and b, and the command is integrate dot romb y. See, there was the difference between the trapezoidal rule, Simpson's 1/3 rule, and Romberg integration rule. Romberg will just perform the simple integration over the interval, and the command is very simple, integrate dot romb, R-O-M-B. Now see, my dear friend, when you perform the integration with the help of numerical methods, then it will take a lot of time, and definitely the chances are there to get the wrong answers also. But with the Python, just we need one command, like integrate.trapz. It will perform with the trapezoidal rule. Integrate.simpso and Simpsons, it will perform integration with Simpson rule, and integrate.romb, it will perform with romb. So you need not to worry that how we are going to calculate. Just we need to select the rules, and we will put the command, and then we'll get the integration. So in this way, I can say that the Python language will help us to perform the numerical mathematics or computational analysis of mathematics in a very much and simpler way. That is the advantage of Python language and beauty of Python. So here I have completed the module 4 of all the topics. Thank you very much. And we are going to start the next topic will be module 5. Thank you.